Okay, so please listen. There were 3 investigations.
Oh God.
Where did they come from? That must be the primary case. There were 3 investigations you were asked to do. It's all about transformation of the shapes. Transformation of functions, sorry, not shapes. In middle school and lower secondary, if I may put it that way, because now you're in upper secondary. In middle school and lower secondary, you did something on transformation of shapes, right? Can you remind me those transformations that you did in IGCSE? Yes, sir.
Translation.
Translation. What does translation mean? Anyone else? Someone else? When you hear translation, what comes to your mind? One word. Begins with S. SL. Not SL math. Say that again. Sliding. Okay? Sliding. That's what translation is about. Okay? Similarly, we can discuss this translation of functions. Okay? What do I mean by this? Thank you, Joey. We have our XY plane. Okay? Please pay attention. We have our XY plane. This is a function f of x. Okay? This function can slide left and right, up and down. When it slides left and right and up and down, the equation that generates this function changes. Do you agree?
Yes. Yeah.
But that equation has a relationship with the original one. That was what you investigated in one of your homework. Can somebody tell me which of the investigation, 1, 2, or 3? One is about that. When I gave them last year, I put the name translation. I think it's like shooting myself in the foot because now they understand, oh, this must be about translation. And I was about doing the same, so I quickly changed it. I'm just going to call it investigation 1, 2, 3, and you figure it out yourself. And I'm glad you did. Now, if you move to this point by a step of, say, 4 units, you're going to end up getting a function that looks like this. Alternatively, or similarly, you can move 4 units here. This is not 1. I am just trying to put a notation. 4 units here. Okay, let's say this is minus. Let's say this is minus 3. 4 units will be 1. It's on 0. So let's say this is another function whose x value is now 3. So that means 6 units, then up by, let's assume this is 2, up by 2. So the original function f is now being moved around. What will the equation of the other function look like? That's the first question. But that, which is probably going to be the easy one, because you can easily see the picture and you can get it. But in IB exam and any other interesting exam, the equation of the original function will be hidden. And you'll be asked to sketch the new function by giving you a relationship with the original function. That is the next, that was the reason I gave those investigations. So you can see it yourself. Okay? So let's play with what you might have discovered. And let everyone learn from, whatever the case is. Now, before I start, because I want to do the 3 transformations together, because of our time, rotation is the only one we don't talk about in this syllabus. Because remember in your IGCSE, you did translation, what else? Reflection, then? Enlargement. Okay? Then you do rotation. Okay? So rotation is the only one that we don't talk about. You've done rotation with matrices in IGCSE, remember? Anyways, so that's about that. The second one you talked about again here is reflection. You can reflect a function too. If I have my xy plane, I have this function x squared plus 1. I can reflect it along the x-axis. Agree? if I reflect it along the x-axis, I'm going to get something like this. What will the equation look like? That's one question. Am I making sense? Alternatively, I could reflect it along the y-axis. If I reflect this black one along the y-axis, what does it give you? Say that again? The same thing. Because if you reflect this, you get this back. Reflect this, you get this back. Why is that the case? Anyone? It's symmetrical about?
The vertex.
How do you know it's about y-axis this time? The vertex is on the y-axis. If the vertex is not on the y-axis, it's not symmetrical about, it's not going to look like that. So for example, if we have this, it's not going to look exactly the same, that's my point. If you have this, such that you have this. If you reflect it along the y-axis, this will come here. The reflection of this will be here, agree? And the reflection of this will come this way, something like this.
Yes.
You understand? So it looks like a W. Okay? So this is reflection of functions, or graph of functions. The other thing that we're going to practice today, it's about, what's the other one again? Translation, reflection, and enlargement. But we call it stretching. Stretch. Not the stretching you do during the break. But you know, same. Or dilation. It means we can compress or enlarge a shape. In this case, the shape in question is the graph of a function. Am I making sense? So we will see the connection between the original function f and the new one as a result of this transformation. Okay? And later we will combine 3 transformations, or more than 1 transformation, not necessarily 3. More than 1 transformation sometimes. Okay. So let's look at the first one. In the investigation, I said f of x is x squared. So let's plot x squared. Okay? Then I said on the same axis, plot f of x plus 2, which means x squared plus 2, right? X squared minus 3, x squared minus 4. If you haven't done this investigation, raise your hand. Okay, everybody has done it. Thank you. So let's see, x squared, so I'm just going to copy. I'm lazy, I know. Plus 2, plus 1, minus 3. There's a minus 4 also? Why did I put so much? That's okay. Can we see?
Yes.
Let's connect each of them to the original function. One sec, please. Oh no. Okay, it's bolder. Let's connect each of them to the original function. So let's take one by one. Look at this. Did you notice anything?
Yes.
What do you notice? It moves upward by 2, right? For this one, it moves upward
by 1.
For this one,
Down by 3.
down by 3. And this,
Move down by 4.
so which means if you have f of x plus k, the graph will move
K.
k units upward if k is positive, and k unit downward if k is. Now, I asked one of the, in the investigation I asked, will the shape of the graph change or not?
No.
Did I ask in your class?
Yes.
Okay, because I gave Form 3 an investigation. I want to be sure I'm not mixing the language of my question. But this is not their investigation. They are investigating turning points using x minus k all squared plus h. Remember that?
Yeah.
So that's what they are doing. All right. So adding a number is responsible for your vertical sliding, right? Slide up and down is responsible. If you had a positive number, it means from wherever you are, go up. Negative number, from wherever you are, come down. The same shape, copy and paste, just slide it. Okay? Now, then after that, you were asked to Now I say comment on whatever, well, I'm sure you were able to write the right comment. Can somebody remind me what they have written in B? Consider the graph this. Comment on the effect of K on this graph when K is greater than 0 or when K is less than 0. Yes, anyone? Come on, we just discussed it now. Yes, just try. Yes, Joey.
I wrote for K, well, I mean when K is larger than 0.
Hold on. You
Yes.
see the beginning? I asked for two things. A preamble was to separate them. When K is greater than 0, please continue.
When K is greater than 0, the graph moves upwards. And then when K is smaller than 0, the graph moves downwards.
Can somebody tell me why I may not accept that as a full explanation? Denise. By what unit? By K unit. Thank you, Denny. By K unit is very important. Okay? Because when you say move upward, it means if you move upward one time, it's the same as you move upward 10 times. But they are not supposed to be. You probably didn't miss that in your writing, which is fine. Or did you miss that?
Yeah.
You missed that.
Yeah.
But now you know. Okay. Now, let's see f of x versus this red. The same x squared, right? But this time around, it says f of x plus 2. We have done function, right? I don't want Joey getting up all the time, so let's move this beside the board. Joey, can we see this a little?
No.
No?
It's okay.
Sorry. Because I don't want you moving around all the time, that's why.
Okay.
Oh, if you have to, just put it here, it's better. Here, thank you. Everyone, if I have f of x is x squared. Carolina, f of x plus 1 will be what?
In brackets x plus 1 squared.
We are only changing the point from x to x plus 1. So wherever we have x, we also be changed to x plus 1. Because this is just a box, right? F of something is equal to whatever something is squared. So whatever you have in this box is here. Understand that? Then you don't have to expand it. Okay? So don't waste your time expanding. Who expanded before plotting on the graph?
I might have.
So you don't have to expand it. So f of x plus 1 will just be x plus 1 all squared, like that. We don't need these guys anymore. Get out. Okay? The other one is, oh sorry, this is 2. Then what we have again? Minus 3 and minus 4. Okay, great. So let's, no noise please. And we change this color to something else. Trying to use different colors so we can differentiate. I think we haven't used this one. Okay, great. We're good now? So let's remove this. Now, Rita, compare the first one, which is in red, to the new one in orange. What do you notice?
The orange one.
No, hold on. The original function is in red.
Yes.
So tell us what happened for you to get the orange. So you shouldn't start from the orange, you start from the red.
The red one moves to the left for 2 units.
To the left by 2 units. Can someone tell me what, okay, maybe when I'm done with this. Now look at what happens to this one, the purple. Jensen, what do you notice about the purple? From the red to the purple.
From the red, it moves to the left by 1 unit.
By 1 unit. And similarly, everyone, what happened to blue quickly?
To the right, 3.
And this moves.
Right, 4.
Now, one question. What are the likely error? Okay, in general now, if I say x plus k squared, will it move right or left? If my k is positive, of course. It will move left, right? But if my k is negative,
Right.
What do you think the likely mistake you can make as a student?
You think that positive will move towards the right and negative move towards the left.
That's very common mistake. You may think, oh, plus means move to the right, minus means move to the left. That's a common mistake. All right? So try to avoid that. They are just traps. It's easy. Can somebody remind me of another common trap in a recently discussed topic? Or let me say quadratic.
Positive. Wait, the concave up.
Concave up and concave down. So what are the likely traps that you think people can fall into?
It's the maximum is positive. And
What is positive?
is when the A is
Exactly.
positive, and then the minimum is when the A is
That is it. Oh my God, I love this. When A is positive, people might mistakenly say, oh, that must be the maximum because, oh, positive, right? It's a common trap. We have to be very careful. So we have seen that this number here is responsible for the horizontal slide. And when you have negative, you get to the right. When you have positive, you get to the left. Then I ask you to make a conclusion, I think. Okay, I think the conclusion was, because it's the same for other functions, so I don't want us to waste too much time. Okay, let's look at it. I said describe the transformation which maps f of x onto f of x minus a plus b. Who wants to go for that? Let's try someone else, not Joey. Yes, sir.
Translation of A comma B. You know the vertex, the tall brackets.
How will you write it in an exam? You're not going to say you know. Just give me a statement you will write in an exam.
Okay.
Describe the transformation that maps f of x onto f of x minus a plus b. Anyone? Yes, Anson?
The graph moves to the left by A unit and moves up by B unit.
I can accept that for someone in Form 3. Now tell me like a Form 5 student. Yes, sir.
Translate f of x by negative.
Speak louder, sir.
Translate f of x by negative a and b,
By negative a and
comma b.
comma b.
In brackets.
Something is still missing.
Positive A.
No, this is
Something is still
Oh,
missing.
yes.
You said translate f of x by negative a comma b. What is wrong with that use of mathematical language or notation? Remember, IB is not just about plus or minus. Getting the right answer. Your communication is key. There's something you have not said. It doesn't matter. Yeah, you are right with that. There's just one.
From the previous coefficient.
No, okay. So you said transformation which maps this into that. So you can say f of x is translated, right? F of x is translated by, it's a vector, by the vector AB. Even in IGCSE, don't we write vector?
I said long brackets.
But vector is not that, it's not ordered pair. Hello? I heard people saying A comma B. Can somebody tell me why this is not acceptable?
Because that's a coordinate.
That's just a coordinate on the Cartesian plane. Okay? Not a vector. So please, as much as we get the right answer, your presentation matters too. Your communication, remember, is one of the criteria. Okay? So f of x is translated by vector a comma b. That's the transformation that maps it into that. Yes, sir.
How would you type the vector in?
In Microsoft Word?
Yeah.
Oh, easy stuff. Piece of cake. So type any equation, ought and equals to. When you get that, you come here. You just pick one box. You can pick the box from here, or you may just write.
Oh.
Where does that come from? You can pick the box, or you may just put this. Once you put this and you put a space, it's the same as coming here to pick this box. So inside the box, go to matrices and pick a column matrix. That's it.
Oh.
So this is your A, this is your B. That's it. Okay? Any maths, just type alt equals. Alternatively, come to insert, then find equation somewhere. Yeah, it's here. Okay? But I don't know what it will be like on Mac. Sorry, I'm a Windows person. So that's that. So the last question quickly. Does any of this transformation change the shape of the graph?
No.
No, because you're just sliding, right? So you're not doing anything, you're not changing the shape, the size, you're just changing the position. Now, look at the, or maybe we can explain everything before you do the first one, right? No, let's stop the recording. Look at the first one, hold on before you stop it. Everybody look at your worksheet. Everyone look at your worksheet. May I share that of Jensen? You can look with Marco. So if you look at the first page, can everybody see it? On the first page, it's actually here. Sorry, hold on. Jensen. I have it, so I don't have to stress him. If you look at the first page, you will notice this is the original graph. Hello? This is the original function. Everybody please look at the board. This is the original function. So this function has been drawn for you in 3 times on the first page. So on the first page, I need you to sketch the graph of the function stated based on what we have just talked about. Then if you go to the second page, you have something more interesting. Okay? So there are 6 questions. I believe we should be able to do this within 5-6 minutes. All right? Good luck.